My name is Oktay. Today's video is about alloys. Alloys are metals with one or more chemical elements. This can be a metal or non-metal element. Here are a few examples of alloys. You can have a substitutional alloy, an interstitial alloy, or a combination of both. And alloys are known for new properties compared to pure metals. They can have a higher corrosion resistance, better mechanical properties, and different melting points. This is historically a very important alloy. That's bronze. It's a copper alloy with 12% tin. It can also contain aluminum, manganese, nickel, zinc, phosphorus, silicon, or arsenic. Melting point is 950 degrees Celsius. That's an advantage. And the Bronze Age lasted for over 2000 years. And it was followed by the Iron Age. This picture is of a funerary bronze helmet from 540 to 530 before Christ from Pella in Greece. There are two more examples of bronze pieces. At the left is the Nebra disc. It is dated 1800 to 1600 before Christ, and it shows that back then people made astronomical observations. At the right you have a Hattusa bronze tablet from 1235 before Christ. It's a treaty document, and you can see it contains many letters, a lot of text, and that's because they have listed all the gods in this treaty document. This document is from today's Turkey. Hattusa was the capital of the Hittite Empire, which is located in Anatolia, Turkey. The picture shows you the gate of the city with lion statues. One compound bronze is patina. This greenish surface. You can see that, for example, at the Statue of Liberty in New York, USA. This is a statue of the goddess Libertas. She was the goddess of liberty, and usually this patina is wanted because it gives the surface structure and depth. Patina is a mixture of copper chloride, sulfides, sulfates, and carbonate. This is another very important alloy. That's steel. It is iron with up to 2% carbon, and steel has, compared to pure iron, a higher strength. This is an example of a structure, steel structure. That's the Murinsel, which is located in the river Mur at Graz. That's in Austria. It's a floating structure of artificial island. This is how the interior looks like, the typical steel construction. This is the gangway through the structure. Iron alloy with more than 2% carbon and 1 to 3% silicon is called cast iron. Has a melting point of 1150 to 1300 degrees Celsius. Is used for pipes, machine parts, fans, and hand tools. Electrical steel is an iron alloy with 3% silicon, and it contain manganese and aluminum. This picture shows you its polycrystalline structure. It's a magnetic alloy and is used for relays, electric motors, and generators. Steel production is a big part of the global economy. The world production was almost 2 billion tons in 2021. About half of it is in China. And steel production is a carbothermic reduction of iron oxide. This is a source of CO2 emissions. About 11% of global CO2 emissions comes from the steel production. And the alternative is a reduction with hydrogen. Stainless steel is an alloy with about 11% chromium. This is an example, the SpaceX Starships SN15 and SN16. They have a height of about 50 meters, diameter is 9 meters. They can carry a payload to up to 100 to 150 tons, and the propellant mass is 1200 tons. This is the same principle as in soda cans. The propellant with its pressure helps stabilize the structure of this rocket. Not only the composition of an alloy is important, but also its treatment. This is one example that's called precipitation hardening. This is a special heat treatment produces impurity particles, and these particles give the alloy strength. Alnico is another iron alloy. It consists of iron, aluminum, nickel, cobalt, copper, and titanium. It was discovered in 1931 by Tokushi Mishima, and it's a permanent magnet. Magnets are known since 600 before Christ, and they are named after the Greek city Magnesia. Brass is a copper alloy with zinc, arsenic, lead, phosphorus, aluminum, manganese, or silicon. They have a gold-like color, low melting point 930 degrees Celsius. They have a corrosion resistance, and they can be used for locks, hinges, gears, bearings, valves, sockets, and instruments. Solder is an alloy of tin with lead and 1% other elements. Its melting point is between 90 and 450 degrees Celsius. The solder is used for electrical connections, for electronics, fire sprinkler, air conditioning, and heating. Pewter is another tin alloy with antimony, copper, bismuth, and silver. Its melting point is 170 to 230 degrees Celsius, depending on the composition. And pewter is used for decorative objects, models, coins, and jewelry. Babbitt is another tin alloy with antimony and copper. It was invented in 1839 by Isaac Babbitt. It is known for its resistance to galling. Usually it is used as a thin surface layer, for example for compressors, turbines, and electric motors. Sterling silver is a silver alloy with up to 7.5% copper and other elements. Sterling silver has, compared to pure silver, a higher hardness and strength, and it has a reduced tarnishing. This picture shows you the bicentennial bowl with motifs of 200 years of history, and the inner parts are made of gold. Electrum is a gold-silver alloy with traces of copper and other metals. It was used for coins. This is an example from the 4th century of coins made of electrum. White gold is used in jewelry. It is an alloy of gold with silver, nickel, palladium, or platinum. Rose gold, with its reddish color, is an alloy of gold and copper. It is also used for jewels. And there's a special kind of crown gold, which consists of 22 karat gold alloy with 8% copper. And crown gold is used for coins. This is a picture of amalgam with this alloy of mercury with silver. Amalgams are alloys of mercury with other metals. For example, dental amalgam is mercury alloy with silver, copper, indium, tin, and zinc. Woods metal is a bismuth alloy with lead, tin, and cadmium. It was discovered by Barnabas Wood in 1860. There's a very low melting point of just 70 degrees Celsius. And that's why you can use it for as a fire-melted valve element in fire sprinklers. Since it contains lead and cadmium, it is toxic. Bimetals are not alloys because they are the metal atoms are not mixed. Bimetals have layers of different metals or alloys with different expansion coefficient. And this picture shows you what happens if it is heated up. The bimetal stretches. Bimetals can be used for thermometers, thermostats, clocks, and blades for saws. When the bimetal cools off, it will go back to its original shape. Now you can see it. Nichrome is a nickel alloy with 20% chromium. It was discovered by Albert Marsh in 1906. It is used for resistance wire, heating elements, and dental fillings. AJ62 is a magnesium alloy with aluminum, strontium, and manganese. It has a good creep resistance at high temperatures and is lightweight because magnesium is a very low mass. And AJ62 can be used for engine parts. This is a picture of Ashtadhatu. This is an octo-alloy of gold, silver, copper, lead, zinc, tin, iron, and antimony or mercury. This picture in the middle is the statue of the goddess Shakti, Hinduism. Shakti is a goddess for primordial cosmic energy. That was today's video about alloys, which are customized metals. Thank you for watching. Have a nice day. Bye bye.